There are many different approaches or models in machine learning, but generally they can be broken down into two major categories called supervised learning and unsupervised learning. I'm going to use a lot of new terms here that might be confusing at first, but don't worry, I'll break each one down a little further after the initial explanations. You might want to pause the video periodically to read the teacher notes as each concept is introduced. You might also need to go back and rewatch parts of a video to review. Let's start with an important vocabulary word. When you hear the word model or algorithm in reference to machine learning, it essentially means an approach to the problem. A model in machine learning is just like an architectural model or a dollhouse. It's a simplification that attempts to simulate or demonstrate some aspect of the real world. Meteorologists use weather models to try and forecast the weather because even all the computing power in the world couldn't perfectly simulate every tiny air particle and temperature and pressure change that would influence the outcome. So instead, we can use a model to simplify the problem and get a useful approximation of the result. A model in machine learning is typically probabilistic. In other words, it usually does not produce an exact result. Rather, it makes a prediction with a corresponding percentage of confidence. This isn't something you need to understand in great detail, but it's good to know the basics. Probability is a means of expressing how likely it is that an event will occur, or a way of measuring how close a value might be to the actual correct value. Probability is typically quantified as a value between 0 and 1, with 0 being a complete guess and 1 being complete certainty. For example, if you're rolling a die and hoping to roll a 2, you have a 1 in 6 chance of rolling a 2 because the die has 6 sides and only one of them is a 2. 1 divided by 6 is 0.16 repeating, or a 16.6% chance. This is relevant to machine learning because if a prediction is far outside the norm, the model might have low confidence in the answer because it's highly probable that it's not correct. If the prediction matches up almost perfectly with an existing example in a data set, then the confidence will be very high. Now, with the definition of a model in mind, let's take a look at the two major categories of machine learning. The first of the two categories for machine learning approaches or models is called supervised learning. Supervised learning is when a machine intelligence is tasked with predicting a category or a quantity. Predicting a category or a quantity comprises the two subcategories of supervised learning, which are called classification and regression, respectively. Put another way, a classifier looks at a piece of data and tries to categorize it, or in other words, classify it, and a regression tries to predict a quantity or a number. The second of the two major categories is unsupervised learning. Unsupervised learning is when a computer analyzes unlabeled data and has no previous examples and tries to identify patterns in the data. One of the most common subcategories of unsupervised learning is called clustering, which are models that attempt to group similar things together. Because the learning is unsupervised, the model's definition of similar might be different than our own. Regressions, classification, and clustering are not the only approaches in the two categories of supervised and unsupervised learning. There are many more, and you should check out the notes associated with this video for more resources. That's a lot of concepts all at once, so now let's focus and break things down further by thinking about an example application for one of these, starting with supervised learning, and one of its subcategories, classification. Let's say you want to classify an email as spam or not spam. You could give a machine intelligence millions of email messages that are already labeled as not spam and millions that are labeled as spam. With each example message, you would identify features of the data, like the subject line, the sender, the body of the email, the attachments, and so forth. Then, when a new email comes through, the machine intelligence can refer to all of the features of the spam and not spam messages and decide how closely the new email matches any patterns in the data. Then, it assigns a category to the new message with some percentage of confidence. In this course, we're going to create our own classifier that will attempt to label new entries into a dataset based on the existing data. However, for completion, let's take a quick look at regressions and clustering. A regression is another type of supervised learning. Instead of attempting to categorize data, it tries to predict quantities. For example, say you're opening a restaurant and you're trying to decide how dishes should be priced. A regression algorithm could look at a data set of other restaurants in the area and use features like the average price of a dish, the relative distance to the new restaurant's location, the average review score from Yelp, and so forth. Based on that information, the regression could try and predict appropriate prices. The last approach I mentioned is called clustering, which is one of the biggest categories of approaches to unsupervised learning. Have you ever been on a social network and been shown suggested friends or targeted advertisements? Or have you watched something on a video sharing site that shows you suggested videos? How do these websites know what to show you or what content is similar? A cluster analysis can attempt to group data by similarity without attempting to apply any type of labels. This cluster analysis might help to identify hidden patterns in the data and automatically group things together based on features of the data. This was a broad overview of the different approaches to machine learning, and as you can imagine, it's a deep topic with lots more to explore. I encourage you to check the notes associated with this video to help review what we've learned. I also want to mention again, don't worry if you're not understanding everything right away. In upcoming videos, we'll take a closer look at some of these concepts. Machine learning is a huge area of study, and it might take some review for you to fully absorb everything. Remember, you can always go back and re-watch videos if you feel like you need to.